Okay, let's get started. The first, I wanted to share my screen. Okay, so when I get here, so I was. Okay. Okay, this chapter we're gonna learn volatility, chapter 10. So what is volatility? Okay, so the first we going to define what is volatility. So remember, so we talk about return, and volatility, it basically is a measure of risk. Okay, remember, so we have standard deviation to measure the risk. Okay, this one, the volatility is similar to that. If we have the value, okay, SI is the value of a variable on day I. The volatility per day is the standard deviation. If we take the ln of the price of today divided by SI minus 1 is the price of previous day. So that's how you get the volatility. Okay. So normally the days when market are closed are ignored in volatility calculation because the daily volatility is too volatile. So we're using a much longer time period to measure volatility. And so, for example, we're using volatility per year. So that's the yearly. Okay. So the yearly volatility is the square root of 252 times the daily volatility. Okay. So if we square that volatility is called variance. Okay. So in another way is that in order to calculate the volatility, typically we take the square root of variance. Or you see the variance is the square of volatility. In finance, we usually calculate the volatility is based on the variables, and it's called implied volatility. So of the variables needed to price an option, the one that cannot be observed directly is a volatility. So we can therefore imply volatilities from the market price. Okay. So recently you can see in the stock market, so we measure that implied volatility. You can see it has a big spread. So this is the graph showing that the VIX index. Okay, the VIX index is sometimes we call a fear index. Okay, so to measure the people's panic in the financial market. So the VIX index, when it's starting to increase, if we get a big spread, that means more likely during the financial crisis period. So the same thing happened in the past couple of weeks. So we can see the VIX index, okay, they have a big spread because a lot of people are panic about the coronavirus and how that's going to cause the negative effect on the investment. So the VX index basically is a measure of the volatility and also investors' fear. Okay, okay. So exchange rate. So we talk about the exchange rate daily changes. Is that normally distributed? We measure the return of the financial asset. Okay, measure the return of financial asset is that the normal distribution is we see the standard deviation and also the mean. So it's we know that normal distribution curve is that most the value will be close to the mean. Okay, close to the mean. So we can see this is the real world percent about 1 standard deviation, and this is normally the model is higher than the real world. So why that happens? Because the financial asset return in the financial market is not typically normally distributed. We assume that it's normally distributed, but that normal distribution typically we call as they have a fat tail effect. Okay, so what is that? The fat tail is a heavy tail. Is so this means that small change and a large change are more likely than the normal distribution would suggest. Okay, and so so the return of the foreign exchange or stocks, okay, is a normal distribution, but with a heavy tailed distribution. Is so we can see the right curve. Okay, is called a heavily tailed. Okay, so sometimes we use the term is called fat tail. So you can somewhere I will Google fat tail. So that's what we typically use. Okay. Stock return, fat tail stock returns. So a fat tail is a probability distribution which predicts movement of 3 or more standard deviation, okay, more frequently than our normal distribution. So the tail risk or fat tail, so we can see how the picture, hopefully they have a picture looks like that. Okay, we call this one as a fat tail. Okay, and so just give you a mind that the fat tail is like the blue curve is a typically normal distribution we observed. Okay, but the fat tail is that the chances of having an abnormal loss is higher than what you think. Okay, so that's why the stock market, okay, is something that might happen. Okay, and this get a heavy loss. Okay, this could happen, and this picture give you a more clear picture what fat tail means. Okay. Okay, so we just have some basic concept, and now we we just go to use the data we have and to tell you how to calculate the volatility or how to estimate volatility. And in this week, we have the assignment, and some students asked me the deadline for that assignment. Assignment 3A is due this coming Sunday. It's April 5th, because it's not last Sunday. So sorry for that mistakes or confusing. Okay, to estimate volatility, and we use a standard approach. So the standard approach is we define that delta as the volatility per day between day N1 and day N, okay, as estimate at the end of the day. So you get SI, the value of the market variable. If you choose a stock, the SI is going to be the stock market closing price. Okay, and so this is the mu is going to be ln. Okay, ln of the value of today divided by the price of previous day. Okay, this is how you calculate the daily return. So that's basically most of the researchers they use is just take the ln of the division of the price, closing price. So once you do that, okay, so you take the average. Okay, so M is the total number of observation. Okay, total number of observation, which is M. So you take M. Okay, you sum all those values and take the average. Okay, that's a expected return. And then you take the deviation and then you sum them up. Okay, you know that this is the variance. Okay, the delta squared, that's the variance. And then you take the square root of variance. That's your standard deviation, which is the volatility. Okay, this is one way we use. Okay, take the ln of the deviation of the price. There's another way we also use, a very common is that, so we use the price difference divided by the price of the previous day. So that's another way. Okay, is simplifications usually made in risk management. So we another way is doing the mean value of that assumed to be 0. Okay, so now we take the average. We simply take the average of the squared, a squared return is going to be the variance. Okay, the variance, and you take the square root, that's going to be your volatility. Okay. Okay, so we first using the example we have. So I think we can do is using the example we have from table 10.3. Okay. Okay, table 10.3. If you don't want to do this, okay, we already have this documents. Okay, it's 10.3. Upload your course content area. So you go to your Blackboard and course content. Okay, look at week 12. Okay, you click on table 10.3. Okay, so all those formulas and some explanation we got from chapter 10 volatility.pdf. So I have the PDF file and available for you. The table 10.3, okay, this is the Excel file. Basically, I made this based on the formula we have. Okay, the first one, we have the table 10.2. Okay, this is the data we used exactly the same from the textbook. Okay, that's I will say you have this one. Okay, so we use the same data set so that you will know what I'm talking about, and so you can replicate after the class. Okay, so we have the table 10.3, the data for a computation of volatility. Okay, this is exactly the same data. Okay, data set. Okay, the first, okay, so you do is that you calculate the relative price. Okay, the relative price. So what is the relative price? Okay, this is the current price. Okay, equal to the current price. Okay, divided by previous day's price. Okay, that's give you the price relative. Okay, price relative, and then you click on enter. So that's a price relative, and then you drag all the way down. Okay, that's how you calculate relative price. Okay, remember that's the first you calculate relative price, and then you take a ln of the relative price. Okay, so the price is equal to ln of this relative price. Okay, this is the relative price. You drag all the way down. Okay, so this is the ln of the relative price, which is we could move is the return. Okay, the daily return. And we based on this formula, so is called the mean. Okay, the mean. And then we calculate the variance. Okay, the variance, how you do this? Okay, based on formula 10.2 is that the return, the daily return minus the average. Okay, the moon bar is the average, okay, expected return, and take the squared. Okay, so we get the average. Okay, and we have the moon bar equal to the average. Now you have to use the function is called average function. Okay, average, and you sum them up. Okay, that's the average. Okay, now you see this the deviation of the return. Okay, the deviation of that return to the average. Okay. So we have is that the deviation. Okay, so if we do this, okay, we can do equal to the deviation. Okay, this is the return minus the deviation. Okay, the minus the moon. The moon is that you have a squared. Okay, remember you need to put $sign to fix this expected return, which is the moon bar. Okay. Any questions? Okay, good. So this is the one, and so you have this this part. Okay, the squared deviation all the way down to here. Okay, so what I did here, so in my Excel spreadsheet, I moved up one cell, so you can do the same or move down one cell. Okay, now you can see you have to sum them up. Okay, you sum them up. All those numbers we have the deviation squared. You sum them up. Okay. Okay, so what else you need to do? So you have m minus 1. Okay, so remember the m is 20, so you have 20 returns. So the first one is you lose 1 degree of freedom. So M is 20. So you sum them up and use, okay, this is a 1 over 20 times, okay, that's minus 1. That's your the variance. Okay, the standard deviation squared is your variance. Okay, that's your variance. Okay, and then you take the square root equal to QRT, the square root of the variance. Okay, that's your standard deviation. Remember, this standard deviation is also your return. Okay. Okay, so you drag all the way down here. Okay, so that's your standard deviation. Okay, so we use this function and we can have that to get estimate volatility. Okay. Okay, another way we do is that we can do is using formula 10.3, just another way. Okay, so let's say another way we do is 10.3. Okay, the 10.3 is that we do the difference, relative difference. What is the relative difference is going to be, okay, this is relative difference, the price difference. Okay, this one minus, okay. So we have this one minus previous price. Okay, so you calculate the difference and you drag all the way down. Okay, so you calculate the SI minus 1, okay? And then you get this difference and you divide it by the previous day price. Okay, this number is got a relative difference divided by the previous day price. Okay. So you drag all the way down. Okay, so then you calculate the mean, the moon. Okay, the moon is going to be, okay, this is the average. Okay, this is the average. Okay. Now we do the variance. Okay, so we have the variance. How are you gonna get the variance? Okay, the variance is going to be, okay, so look at the formula is that you sum all those together, right? You sum them up, just square those. Okay. So equal to the daily return squared. Okay, the daily return is squared, and you drag all the way down. Okay, so to this line you divide it, and then you see you sum them up equal to, okay, equal to 1 over this M is 20, so we have M 20 and times the sum of this variance. Okay, that's the variance, okay, which is here the function is called the standard deviation squared. Okay. Now you have the standard deviation, QRT, and square root of the variance. Okay, that gives you the standard deviation, and this is called volatility. Okay, so you estimate volatility. Okay, you can change it to percent or whatever. Just okay, so that's the percent. Okay, you can use different way to do to estimate volatility. Okay. Good. Any questions? Okay. Questions? Okay. Next, we talk about is the gauge and weighted moving average, exponential weighted moving average model. I think the students already, maybe you already check your assignment is going to estimate the parameters for equally exponentially weighted moving average and also the gauge 1-1 model. Okay, so we're gonna do the first. We look at the slides we have here. Okay, so we're gonna work on the table is 10.4. Okay, 10.4 is the data we have using from the author's website. Okay, so this is the link to the author's website. I remember in the course content area, I gave you Dr. John Ho's website with data. Because you click on that data, okay, so the you have a download materials for my book. Okay, this is going to be, this is the textbook we use. Okay, so you download data. So the risk management and financial institution. Okay, you click on that. We're gonna use the worksheet, for example, in 5th edition. Okay. This is the data we have is for the gauge and model, and then you use the gauge SP500 data. Okay, that's where you can get the data from. Okay, so I already have that, and so it's in table 10.4. So the gauge model is we do gauge 1-1. So the first, I wanted to read the textbook to understand what is gauge model. So the gauge is that you have the variance, okay, the variance, okay, which is the volatility you're gonna estimate, is gamma times VL is the long run volatility. Okay, the VL is the long run volatility. So what is your long run volatility? I will tell you later. And plus alpha, okay, alpha, and this is the return. Okay, previous day's return squared, and plus beta. Okay, this is the variance. Okay, previous day's variance. So basically, the gauge model says the return we did, the variance is not going to equally weighted. So example, we working on 10.3 and 10.2 is that, so they give equal weight of all the previous days return and variance. So the gauge model says, so the price is more affected by most recent volatility than the past volatility. Okay, what that means? The meaning is that, okay, today's price changes is more associated with last day's price or last week's price than the price changes of several months ago or several years ago. Okay, understand what I'm talking? Okay, good. So in that sense, so we have SP 500, and so this is the data. Okay, SP 500 closing price, and we calculate return. Okay, the return we calculate using the relative price difference divided by the previous day's price. Okay, and then we calculate variance. Okay, remember how we get variance when we're using this? Okay, the variance is just you square that, right? Okay, you take the variance, you see, you just square that. Okay, good. So the first day you have that price, the variance is squared. Okay, so this is so what happens is you see we fix that. Okay, don't want it to mess up there. Okay, so the first day is just square the previous day return. Okay, for the second day, remember, so you're gonna apply this formula. Okay, that's the Gauge model. Gauge model is the formula applied to that. Okay, how this doing that? Okay, you look at the formula is going to be. Okay, so we're using the C 1233. So it's going to be 3 parameters we're using. Okay. Okay, this is the one we call omega. Okay, so this is the we call omega, and that's the parameters. Okay, we estimate those 3 parameters, and this is the beta, and this is the alpha. Okay, so you can type in whatever numbers you have, and because you're subject to the numbers you have is going to be all these 3 equal to 1. Okay, and so you have these 3 parameters you estimate, and then you apply to this formula right here, and you drag all the way down. Okay, the volatility is the variance, okay, squared. Is squared. Why we times 100 is wanted to change it to %. Okay, and okay, in order to get this number estimate, we're using likelihood method. The likelihood method is using the ln function. Okay, so this is the estimation we used to calculate the likelihood. Okay, so the likelihood function is yeah, I think it's somewhere here. Okay, so I will show you the function we did. Okay, so this is the we estimate the maximize the likelihood method. Okay. Okay, this is what we do. Okay, the maximize negative ln the variance minus the return squared divided by the nu. Okay, divided by nu. Nu is the variance. Okay, so we're using 10.12 equation. Okay, so that's how you sum them up. Okay, you sum the likelihood, and then you have data, and using solver. Okay, this is the last step. We're gonna do is use solver. You wanted to maximize this likelihood by changing the variables, okay, which is omega, alpha, and beta. So you select all these 3 different variables, and then you add the constraint. Okay, they add the constraint. So remember, this is to click on solver, so you can solve this function. You can solve that, so it will change the value. Keep that value. That's how you get the omega, alpha, and beta from the Garch 1.1 model. So I wanted to, because today we stop here, so I wanted to give you some time to practice and to read the course content. You know why we got omega, alpha, and beta, all these numbers, how we got here, okay, to do that practice. And so we continue. So if you didn't practice, you will not understand, okay, for sure. So next, that's why I want to give a couple days to practice. So we're gonna get back to you on Wednesday, okay? Get back to you on Wednesday with more detailed calculation of the Garch and exponential weighted moving average. And so you know what I mean, okay? Okay, any questions? Okay, good. I'm gonna end the meeting right here. So we'll see you on Wednesday.